Hello all. I'm super glad and excited to talk to you all today cause this is the episode centenary and we are having today the centennial celebration. Today's special talk is all about acetylcholine. Welcome all to Is Pharmacology Difficult podcast. I'm your host Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Now, so far we have all known that acetylcholine is the most important neurotransmitter at almost all the sites, and to know its course in our body, we ought to know about its synthesis. Now, there are three compounds you have to understand, namely adenosine triphosphate, which is abbreviated as capital ATP. The second one is acetate. Then we have coenzyme A. All these three, they are activated together to form acetylcoenzyme A. Now, what is the whole process? First and foremost, choline is transported from the extracellular fluid into the cytoplasm via energy-dependent carrier system. It is uptaken with the help of sodium-choline cotransporter, and its further acetylation follows with the help of ATP and coenzyme A. All this reaction, it occurs in the presence of choline acetyltransferase, which catalyzes this whole reaction. And what do we get as an end product? We get acetylcholine, while the coenzyme A, it dissociates. I hope you understood till far. There's no problem. Let's go further. The acetylcholine formed, it is stored in the presynaptic vesicles with the aid of vesicle-associated transporter, which is abbreviated as capital VAT. Now, this process is active transport. Okay? Now, along with the acetylcholine, the vesicles, once they are matured, they also contain ATP and proteoglycan. You see, I just want to mark it here that co-transmission is almost a rule. It's not an exception. Hope you remember. We did co-transmission in our last episodes. Now what happens further? As and when the action potential it arrives by the voltage sensitive sodium channels at the end of the nerve, then what happens? The voltage sensitive sodium channels on the presynaptic membrane, they open. Now, once they open, the concentration of the calcium increases intracellularly. As the intracellular calcium concentration increases, it enhances the fusion of the vesicles with the membrane. The acetylcholine, it is released in small multiple quanta. Now let us know some details about this whole interaction. Now there are proteins associated in the vesicles. One of them is the synaptobrevin, and also there are proteins associated with the nerve membrane, and its name is syntaxin. Now when the interaction occurs amongst the synaptobrevin and the syntaxin, then the fusion of the vesicles with the membrane occurs. Okay? So you got the essence of synaptobrevin and syntaxin proteins. Okay? Now, before I continue further, it's high time I want to talk about some important compounds which are associated in the synthesis and storage of acetylcholine. The first one in my list is hemicholine. It's one of the compounds that can block the uptake of choline by blocking the sodium cotransporter. Now you should know that the uptake of choline is a very important step in the synthesis of acetylcholine. This is the rate limiting step. I repeat, the the uptake of choline is the rate limiting step, and this can be blocked by hemicholine. Got it? The second compound in my list is vesamicol. Vesamicol is one of the compounds that can block the capital VAT, that is vesicle associated transporter. And if it can block capital VAT, it can block the transport of the choline into the vesicles. That's so easy. Coming over to our next compound, black widow spider toxin. It can cause a wholesome release, a massive release of the acetylcholine, and then it promotes its depletion very, very quickly. And the last compound in my list is botulinum toxin, which is derived from Clostridium botulinum. Now, it does the opposite job to the black widow spider toxin. It can actually block the release of acetylcholine into the synapse. And how does it do it? I told you about synaptobrevin. So botulinum toxin, it causes alteration in the synaptobrevin, which is the protein associated with the vesicles, and that is how it blocks the release of the acetylcholine into the synapse. Now, the toxicity of botulinum is actually known as botulism, and this is fatal because of the respiratory paralysis that it causes. Got it? So these were the details of few of the compounds which are very important to understand and remember when you study acetylcholine synthesis, storage and release. Now we have done up to the release of acetylcholine. What happens next? Acetylcholine, once occurs into the synapse, it diffuses into the synaptic space, and its basic aim is to bind to the receptor, to the target cells, to the presynaptic receptors. And for your current knowledge, I want to say there are two types of main receptors, muscarinic receptors and nicotinic receptors. Now, for the time being, this much is enough. We are not going into the details of the receptors. All the details and the confabulations about the receptors will be discussed in the upcoming episodes. Now, the release of the neurotransmitter is involved as an interaction of the action potential and the calcium entry, and this can be blocked or prevented by local anesthetic agents, or another compound that can block or prevent it is tetrodotoxin. All done up to the release and the action of the acetylcholine into the synapse. The last point is the degradation of the acetylcholine and the termination of the action of acetylcholine. Let us know about it. For this, we need to understand about the compound and the enzyme choline esterase. What happens? Once the acetylcholine is released into the synapse, the choline esterase, which is present there, it acts to hydrolyze it. And once acetylcholine is hydrolyzed, its action is terminated. It is hydrolyzed into choline and acetate in no time. Because a lot of amount of choline esterase is found in the body, so generally acetylcholine takes no time to degrade. Now, the choline which we get as a degradation, it can be recycled by uptake via the high affinity system and converted back to acetylcholine. The vicious cycle continues. Since I told you there's a good amount of acetylcholine esterase, so the action of acetylcholine is generally transient in nature. Its use clinically is very, very insignificant. Finally, before I wind up today's topic, let's get to know about the types of cholinesterases. Yes, there are types of cholinesterases. The first one is the true cholinesterases and the second one is the pseudo-cholinesterases. The true is known as the acetylcholine esterases. What are its features? It is specific in action. The pseudo one is known as butyryl cholinesterases, and its important feature is that it is non-specific in action. Let's get to learn some more important points and differences amongst the two cholinesterases. Acetylcholine-esterases, which is found at the cholinergic sites in the gray matter, while butyrylcholineesterases is found in plasma, liver, intestine, and white matter. Acetylcholineesterases causes a very speedy hydrolysis of acetylcholine, while butyrylcholineesterases takes a lot of time. It causes slow hydrolysis. Acetylcholineesterases, it aims to terminate the action of acetylcholine. While what is the aim or the purpose of butyrylcholineesterases? A simple hydrolysis of the ingested esters. Nothing more. Now with these important differences, you know what we do? We hit a century today. Yes, we do. Hooray! Simply stupendous. All I can say that I'm highly grateful for the honor and the grace. A big shout out and a lot of thanksgiving to all the prestigious and the distinguished listeners all around the globe. I really pray that this event and this feeling centuplicate. Rejoicing the event, I just want to say don't miss my 100th episode special video on YouTube. It's a simple word of thanks from my end. For all the updates and latest episodes of my podcast, do visit www.ispharmacologydifficult.com, where you can also subscribe for a free monthly e-newsletter of mine. It actually contains a lot of updates about medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you are listening for the first time, do subscribe and follow whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.